Record, and I'm going to start letting people in.
Hello, everyone. We're going to start very shortly. Hello, everyone. Welcome, and thanks for taking the time to join us. It's our privilege to host and present to you today. My name is John West, and I'm one of the tri-chairs for the Tech Titans Blockchain Forum. And I'm also an independent blockchain and crypto consultant, and I work for companies of all sizes, helping them appropriately apply blockchain and crypto. Tech Titans is the largest technology trade association in Texas with approximately 375 corporate members. In addition to blockchain, there are several other focus areas. There's AI, cybersecurity, health tech, data analytics, and others. And I've been a member of Tech Titans for about 3 years, and I can definitely attest it's a valuable experience learning from and connecting with other members and even non-member guests. But in addition, Tech Titans does great work in helping develop and promote North Texas in the technology space, helping local schools with STEM, and recognizing tech achievement in the North Texas area. So for those of you that might be interested in membership in Tech Titans, you can contact the sales representative, Barbara Tunstall, and that's a simple email, barbara@techtitans.org. So we're also very fortunate in the Tech Titans Blockchain Forum to have Accenture as the sponsor for our Tech Titans Forum. And at this time, I'd like to introduce and receive some comments from Rich Mazzaros, who is Accenture's Chief Digital Executive. Rich, over to you.
Good afternoon, everyone, and welcome. My name is Rich Mazzaros. I'm a Managing Director in Accenture's Blockchain and Multi-Party Systems Global Practice. Accenture is a leading global professional services company, providing a broad range of services in strategy and consulting, interactive, technology and operations, with digital capabilities across all of these services. We combined unmatched experience and specialized capabilities across more than 40 industries, powered by the world's largest network of advanced technology and intelligent operations centers. With 509,000 people serving clients in more than 120 countries, Accenture brings continuous innovation to help clients improve their performance and create lasting value across their enterprises. Accenture is pleased to sponsor the Tech Titans Blockchain Forum and to bring today's program on trust over IP. John, back to you.
Thank you, Rich, and thank you, Accenture, for your ongoing support. So now for the speakers. Dan Bachenheimer is the technical lead for Accenture's Digital Identity Innovations Organization. And Dan, you can wave. And Drummond Reed is the Chief Trust Officer for Evernym. So you've already seen the attendees, you've already seen the distinguished bios of each of these presenters, and each of their accomplishments and contributions in the identity space is very long and very impressive. And I actually found it difficult to summarize these bios. So suffice it to say that the session description is not exaggerating when it states that we have two pioneers in the digital identity space. So I encourage you to pay close attention and to send in your questions, no matter how big or small, because this is a topic, in my opinion, that we all want to learn more about. So just use the chat, the QA, to send questions in, and we'll monitor, and we'll have a Q&A at the end. And the presentation portion will be completed well in advance of the top of the hour. And if we have lots of questions and need to go on, we can go past the top of the hour. But if you need to break and drop, then go ahead and do that. So as for the agenda, I am going to provide some business and use case context. And then Drummond will explain some of the technology and the trust over IP organization and what it's bringing. And then Dan will actually get a bit more detailed with a specific use case. So we're trying to provide a little bit for everyone from all angles. Go broad in some areas, go broad from both a business and use case and tech perspective, but also then in a couple of areas dive deep to give you a sense of it from all perspectives. So let's get started. Any clarifying comments or anything from my colleagues? Are we ready to go?
Sounds good.
Green. Okay, in a nutshell, what we're talking about today is digitizing your physical wallet, but doing it in a way that is private and secure and easy to use. That trifecta has yet never been accomplished. So what's in a wallet? We all know what's in a wallet, right? Money ID, credit cards, identity, lots of things. And we generally, because it's physical, we try to reduce what we put in our wallet because we don't like carrying it around. So, but there are actually, you know, when you start getting into it, there are hundreds, if not thousands of things that we would carry around in our physical wallet if we could. And some of the examples, you know, beyond the obvious are listed here. So you could have a degree. You could have identity from your bank, or certifications that we get, or a loan verification, or an address verification. Someone attests to your address for schools, or even like your email address. How many times do you have to validate that you control an email address? And wouldn't it be nice as soon as you give somebody the email address, you can also right then and there prove that, yeah, that's my email address. You don't have to send me an email and I have to answer and do all of that Mickey Mouse. So what other credentials are there? There are lots of credentials when you start looking at it. And again, most credentials are physical, and we would carry them around if it were convenient, safe, and private. But certificate of title, birth certificate, wedding license, healthcare information, driver's license, passport, even your employee identity, and the authorization that it has, your payroll, receipts. Wouldn't it be nice if we could digitize the thousands of receipts in a safe, convenient way that we get, or tickets? So hundreds, if not thousands, of credentials that you could have across all areas, all aspects of your life. But we're getting ahead of ourselves. So let's go back in time a bit before the internet. And the main way that people interacted was face-to-face. So one of the first questions you'd be asked is, well, who are you and where are you from and who sent you? And to answer these questions, people would carry lots of different things, special coins or shells, or wax-sealed letters demanding free passage. And today we have passports or driver's license, and we call these things typically credentials or claims or papers or attributes. But credentials seems to be the most understandable to most people. But we also get these credentials from all sorts of organizations. Some we keep in our pockets or bags and use them a lot, all the time. Some we keep in our drawer to bring out periodically, and some we may keep in a safe and bring out very infrequently. But they are ours, and we control them, and we manage who we show them to. And they're used to answer the question, who says they do one common thing? They answer that question, says who. So I can tell a border control that I'm John West, but what they really want to know is, does someone they trust, like the US Passport Office, say that I'm John West? And the most common global standard for carrying these credentials around today is paper and plastic. No surprise. And of course, that paper and plastic doesn't work in the online world. And in fact, the online world has really no equivalent to paper credentials until now. Furthermore, what we've really messed up the online world when it comes to identity and credentials. And it's part of the reason why we have so many hacks and identity theft and misuse of personal data and et cetera. So identity underpins every online transaction that each of us executes. And in terms of that trifecta, it's private, secure, and easy. We don't have an online solution that mimics the physical world that works so well with the old-fashioned paper and plastic. And what did we create instead for the online world? It's actually, I think, quite ironic if you take a moment and stand back and look at it. So our current experience online is you sign up for a new service and you type in lots of data, identity information, and you hand over lots of personal data. And this is bad for both customers and the business. Eventually, what you get back is a username and password that you'll probably forget, and costing you and the business even more time and money. But in a nutshell, you hand over all of your personal information, and hopefully it's accurate, and you get back a user ID and password. And now instead of you holding your identity and personal information, the bank holds your identity and personal information. But they are nice enough to give you a user ID and password. And this happens on a large scale. It's the same story for every service that you interact with. You give them, we each give them our personal information, and they're kind enough to give us back a user ID and password. And you can ask, is that a fair trade? And because there's no global standard for digital identity, then every service has to build its own identity system. And every business has to be an expert in identity management in order to get anything done. It's sort of like driving a different car to every place that you want to go, that you have to own a different car for every place that you want to drive to. So what are the consequences? Well, it's no surprise. Everyone, we know this, our customer data is in these massive data silos that don't talk to each other. And there are not only hackers out there, but even bad behavior from the players that hold this data. And even to the point though, where business is looking at this and saying, I would rather not hold this data. It's too risky. How can I operate without holding this data? But today's identity is really killing customer user experience. And there, I do have another slide, but for some reason it's not showing up. So if we fix these problems, McKinsey says that we will save 1.6 trillion annually. And this doesn't include the value of the extraordinary improvements in the user experience from these changes. So with that as some context, I am going to now pass it over to Drummond, and he can start adding some detail and other color. Drummond. I will stop.
Thanks very much, John. And I will go ahead and bring up, and hopefully I don't run into stuck slide mode because it does happen occasionally. Let me bring this up and see if, tell me if this is
You see it?
showing.
Yes.
That coming up okay?
Yes.
All right, well, I think John did a wonderful job summarizing, you know, just how deep and systemic the problem is. The way I like to describe it, and I've been working for the last 18 months on a book on this topic of self-sovereign identity, is you know, the original architects of the internet, when they created it, it was a fairly small club, and trust was not an issue. And furthermore, it is a very complex problem. So I don't blame them for not putting it in the scope of the design of the TCP/IP stack that the internet's based on. But the lack of building security and privacy and trust into the original architecture was all the problems that John's just gone through. So what I'm here to describe to you today is the emergence of a solution for that, which is called the trustworthy stack, specifically because it is very much like the TCP/IP stack that's based for the internet. It is a common standard way to tackle digital trust anywhere on the internet. And it's a fundamental infrastructural based solution to the whole set of problems that John just talked about. And I'm going to fairly quickly cover so what's behind it, what's the basic design for it, and the new organization called the Trustworthy Foundation that launched at the Linux Foundation in May, that is standardizing and hardening and evangelizing this stack. And Dan Bachenheimer, you hear from next, is also one of the founding members of the Trustworthy Foundation, and he will talk about some specific examples of how that's going to be used. So I'll just dive into this. Now, this is the same slide you saw from John. Whenever I'm addressing an audience, I pull up my wallet right away and I say, ladies and gentlemen, you already know how to do self-sovereign identity. It's just you do it in the real world with your wallet. There, and what makes it self-sovereign is it's your wallet. You control it. You literally own the leather. You control what credentials go in and out of it. You don't necessarily control what credentials you qualify for, you know, who will give you one, nor do you control the decisions of whoever you need to prove something to, like a verifier. Example, we call them verifiers. It might be, if you want to get on a plane and you got to go to a TSA agent, there are only certain credentials they'll accept. And they apply their own policy for what that credential, you know, does your driver's license have blue light on it, right? Is it a legitimate passport? Whatever you're presenting. But that whole system of how we do trust in the real world today around identity and attribute proofing, it works everywhere in the world. We all know how to do it, right? It's just built into it. We carry that wallet with us. We guard those credentials. It's at the heart of how we operate our lives. What we don't have is a model and an infrastructure for using the digital version of those credentials, for doing this online. And so what is at the heart of that, what makes that work is what we call the trust triangle. And this is an actual diagram from the verifiable credentials data model specification at the W3C. And I'm happy to tell you, this is not a work in progress. It is a full W3C standard as of last September. So it's getting close to a year out there. And what it did was standardize the format and signatures for digital credentials. Not a specific kind of digital credential, not just a driver's license or a passport or a diploma or a coffee loyalty card, any digital credential. You turn around and say, okay, I use this overall format and these signature types, and now anyone can design the digital credentials they want. And what makes it inherently decentralized infrastructure is anyone can issue those credentials to any holder that puts them into their digital wallet, who can then present a proof of those credentials to any verifier. And what's really powerful is what can make the whole thing fully decentralized is this magic piece right here called the verifiable data registry, which doesn't have to be, but the thing that's caused this whole paradigmatic shift in digital identity happen is blockchain. So I'm now going to explain why is that the case. I'm going to present the what I call the Tinker Toy version of the trust triangle, and I'm going to step through exactly how it leverages blockchain in a way that's entirely different than cryptocurrency or any other use of blockchain technology. So here we have the issuer holder verifier, and the holder has their digital wallet. And what the issuer is going to do to make this whole thing work is they are going to before the whole process starts, they're going to register a public key, for which, of course, they hold a private key on a blockchain. And they're going to use a second fundamental standard from W3C called DID, Decentralized Identifiers. And I'm the original editor of that specification, been working on it for 4 years. It's now a full a W3C working group. There are over 50 companies involved in its development. And we're near feature freeze. We're about halfway through the final, full version of that specification. And you can think of it as, it's a little bit more than this, but the easy way to think about it is a DID is an address of a public key on a blockchain. And it's like, well, why is that useful? Why, I could get a public key from a certificate authority, or I could have my public key registered with a certificate authority today, and they could sign it, and and that way others could verify it's really my public key or my company's public key. It's great, but that system is centralized. It's expensive, it's got friction involved with it, and that's why most of us as individuals, we don't have public key certificates. You get them for websites, you go through a whole process, but it's centralized, single point of failure, a lot of friction. And when you can turn around and register a public key in a fraction of a second at basically near zero cost on a blockchain, and anyone can verify that once you've done that, you've solved a key problem in distributing, decentralizing public key cryptography. That's why it's called DPKI. So the issuer does that with the key pair they generate. They write that to the blockchain. Now, with the private key, they can sign any verifiable credential they want to issue, which goes to the holder and into their digital wallet, just like you'd put a credential in your physical wallet. At that point, the holder can go any place that credential might be accepted, and the verifier can say, I need a proof of your credential. I need a proof of your driver's license, for instance. That proof, when it comes over, is going to contain, just like the credential did, the DID of the issuer. The verifier can then read from the blockchain. Remember, that's the whole point. Immutable, public, register, nearly impossible to tamper with. And they can read that public key and verify that proof. And they can, now, it all comes down to, they're only going to rely on that credential if they trust the issuer. And that's, that's very powerful. I mean, that's the way regular credentials work. But what's different about this architecture, what's a dramatic departure from the identity solutions we have on the internet today, particularly federated identity solutions like SAML followed by OpenID and OpenID Connect, is that in this architecture, there is no integration needed at all between verifiers and issuers. Today, all the SSO and social sign-on, all the federated systems require verifiers to talk directly to, this is called an identity provider. And they have to be integrated, and it creates privacy issues, it creates business model issues, it creates friction. And in the this new model of SSI, that's eliminated. Any verifier, all they need to do is be able to, they need, a fairly straightforward library of software. There's open source available. The whole Hyperledger project has a stack, the Indy stack, Ursa at the crypto, and then Aries at the wallet layer that I'll talk about in a minute. For doing this, all they need is that software and access to whatever blockchain is used. Now, the thing about DIDs is they can be adapted, called DID method, to any, pretty much any modern blockchain. There are DID methods for Bitcoin, for Ethereum. There are specialized blockchains that are designed just to do this, such as the sovereign ledger. Dan will tell you more about a new one coming called Bedrock. All of these can support and be public utilities for doing this kind of verification. So this is the core model, how the trust triangle works. Now let's take a specific example that to help ground this. And Dan's going to go into more examples, but there's at the NHS in the UK. It's striking me I didn't. Yeah, they are. The problem there they have is COVID credentials. Excuse me, doctors and nurses that need to move across the NHS as nationalized healthcare in the UK. They need to provide proof of their identity and their credentials. They move between those hospitals. Right now, the paperwork associated with that, they're estimated consumes 44,000 doctor hours per year that could be going into healthcare directly. And so they are saying, okay, no, we need to be cutting that out and dramatically lowering that. So here's an example of exactly how they're going to do this, okay? The NHS service is going to be the issuer of those credentials. They're writing their DIDs to the sovereign blockchain. Then they've designed a credential called the doctor's passport. It's just the standard information that a doctor needs to carry to prove their identity as they move around the NHS system. So they'll digitally sign that, give it to the doctor or nurse to put in their digital wallet, which typically is a smartphone application, runs on any modern iOS or Android phone. Then when they go to a hospital or some facility that needs a proof of their license, that hospital is what will read that proof, the DID and the proof, verify it, and again, it all works, the verification, because it's all what we call an ecosystem operated in a governance framework from NHS. So the whole thing works together seamlessly. And let me click here. Yes, okay. I'm realizing I made the mistake, John, of opening the wrong presentation.
That's okay.
Yeah, and it's funny. I had two windows open with two versions of the presentation. I just opened the wrong one. That's
so while you're opening this, there's a question here, so we might as well ask.
Oh, perfect. That's an excellent opportunity. I will find. I will open the.
Yeah, go ahead. In the physical world, the DMV is the authorized by the government, is the only entity allowed to issue you a license. How does that get implemented in digital?
Ah, okay.
So it's issuing a driver's license. How does that get implemented in digital? And how does that like what you just explained?
Exactly. So the, I'm going to get back to, I'm going to get back to this diagram right here where I was and get, because there's a whole section here I want to cover next. Good. Okay.
And actually, you don't have to go into a lot of detail because, well, you can, but Daniel, I think, responded and said he's going to address it in his part too.
Yes, he is. In fact, I'm also about to address it with my section on governance firm is coming up. Okay. So you're absolutely right. It's critical for the verifier to know who is the actual issuer. And in fact, because a DID is not a human recognizable identifier, it's a long string of numbers. You don't know from a DID itself, is this really the NHS or is this really the, Washington State Department of Motor Vehicles? So, but there is an elegant solution to that, which I'll talk about in just a second. All right, so this is the section I wanted to make sure I'm covering. So we've just talked about the critical role of blockchain.
Share, I think, Drummond.
Oh, I'm sorry. Yeah, now I'm back to, all right, let me get right here. And my fault. All right, we're back here and we're back up here and we were right here. Hey, you seeing this, John?
Yep.
Okay. So what I want to stress is we've talked about the critical role of blockchain here and what we call public DIDs that are on a blockchain. But from a privacy and data control perspective, there's a super important point here that I want to make now, which is the role of a different kind of DID for peer-to-peer connections. So you've got a set of relationships here, and I want to point out these three roles, everyone, both institutions of any kind, right, any kind of legal entity will typically play these roles, but everyone will be holders of credentials, both people and institutions. And in some cases, individuals will also be issuers of credentials, in like peer-to-peer reputation systems. It'll all work that way. So we all will play these different roles, but only certain of us will need public DIDs on a blockchain. And this is largely gets to privacy and data control. So there's a second type of DID. It's fully conform with the DID standard, but it doesn't go on a blockchain. And when these relationships are created, for instance, when a holder first go to the issuer, and we'll use that example since we've talked about a driver's license of, if you're having a driver's license issued here, and I'm a resident of the state of Washington, when I go to that issuer, we exchange what are called pairwise peer DIDs. And again, they are DIDs, they are identifiers that are bound to the public and private keys. And so what we're doing is we're exchanging those peer DIDs and the public keys that go with them. But we are only exchanging those privately between the two of us. Each to the other one gives them a private peer DID, and we're the only two parties that ever need to know those. We do not share those DIDs, but what we can do is establish a persistent, secure channel that for all private communications we need to share. So for instance, when the credential is issued to the holder, it comes over this channel, it's already been digitally signed by the issuer and goes into the wallet. Now, when the holder goes to a verifier the very first time, the holder creates another pairwise peer DID relationship there. And it's another secure private channel that it's like as if you compare it to a phone system. Every time you get a contact, every time you handed out a business card, it had a different private phone number on it. And if you ever enter a relationship where you're like, I don't want that anymore, I want to just turn off that communications, boom, you can do that. You hold the keys to that channel, literally. And when you when the whole system works this way, so those who need to be publicly verified, like an issuer credentials has a public DID, but all our relationships we have private DIDs, you have a wonderful solution to privacy by design at internet scale. I want to emphasize what it means is everything above this line takes place entirely off-chain. There is nothing about this exchange or the credential exchange or these relationships. It's on a chain, and this is highly GDPR compliant. In fact, there's a wonderful way in which, when you want to, as a holder, as an individual with personal data, when you want to turn around and say, I want to be forgotten, you solve a hard problem in GDPR, which is how do you prove to the other party that it's really me and I really am asking you to delete me, to forget me, to erase my data. That message can be delivered over this channel, cryptographically verified, and then the appropriate deletion steps can be taken by the verifier, and it can be cryptographically proved by both parties that this message has been delivered and that the actions were taken. So GDPR and privacy regulations, data protection regulations around the world, this is designed for them, okay? So I want to make that point. Now, I want to now answer this question about how do you build webs of trust using this? And it goes to this question, how can verifiers know all the issuers? Well, there's a second trust triangle that we call a governance trust triangle. And that is, you turn around, you add what we call a governance authority. Now, don't think by that we just mean governments, right? Governments are a wonderful example of governance authorities. That's their whole job. But anyone, just like anyone can be the issuer, holder, verifier, anyone can be a governance authority. Typically, it's going to be, it might be a consortia, it might be an NGO, it might be an institution like an academic institution, could be a city, could be a church, could be anything, right? Any trust community that says, okay, we're going to figure out how to publish a governance framework, which is a human readable document with portions that are also machine readable. They can turn around and establish their policies for who are their authoritative issuers, what are the authoritative credentials they can issue, and what are the policies they can issue them under. Now you look at this and you go, well, this is, again, a very well-established model, and I'll give you a perfect example. This is how the global credit card system works. Governance authorities, MasterCard. We have financial institutions all around the world that issue a credential called a credit card to cardholders, and cardholders provide that credential to provide proof of purchase to merchants around the world. This is fundamentally the trust model for the largest trust networks in the world. what we have done with trust over IP is we're standardizing how this can happen to any size trust community anywhere. So you can scale it. So merchants, in this case, merchants can quickly verify, yeah, that's a real credit card from a real bank, and I can rely on that. This is one of the reasons, by the way, MasterCard is one of the founding companies of the trust over IP stack, because they see this same model now being able to be applied to digital identity verification. And if we take the NHS example we just went, in that case, the governance authority is NHS. They actually want every one of their hospitals and authorized facilities around England to be able to issue those credentials to doctors and nurses, who can then go to any other facility to verify them. And all of it will work because of the NHS governance framework, which is an actual government document. And there's one more example I'll give you, which is Dan is quite involved with it, and Accenture, the Mobi ecosystem. There, the governance authorities are folks like car manufacturers that are able to say, okay, dealers, any place could turn around and issue a verifiable credential of car ownership and maintenance and other things like that. And those verifiable credentials can actually be in the vehicle's wallet and shared in some cases automatically into the Mobi framework with things like highways or toll booths or parking lots. So and all of these are what we call digital trust ecosystems. And so I'll wrap this up by saying, how can we standardize this? This is such a powerful new model. How can we standardize this for global interoperability? And this is why we created something called the Trust over IP Stack. The term was coined by John Jordan, the Executive Director of the Digital Trust Service in British Columbia, and now the Executive Director of Trust over IP Foundation. And it's a 4-layer stack. And I'm not going to go deep into the diagram here. I'm just going to point out the first 2 layers are all about establishing technical trust, cryptographic trust, trust about machines talking to machines. The top 2 layers are how you then layer on human trust, trust between people and institutions. And the other, powerful thing about this is it's not just a technology stack. TCP/IP that created the internet is a technology stack, and governance was basically layered over it, things like ICANN and IANA. With trust over IP, we're saying, hey, all 4 layers of this stack need governance by governance authorities all around the world, of any size, of any type. There's specialized governance. We show different types of governance frameworks at all 4 levels, because what you're governing is something different, but they all need governance. And it can be centralized, it can be decentralized, whatever it is. This is how we bind together how technology actually works with the rules we need to achieve human trust. And to just briefly step up through these layers, this first layer is that bottom bar. It's the public utilities. We need the blockchains or decentralized ledgers. Again, there are, each one has its own DID method. There are over 50 DID methods registered now with the W3C DID working group. So there's a lot of competition out there. Some, obviously the permissionless folks like Bitcoin and Ethereum, but also specialized trust over IP layer 1 utilities like Sovereign and Bedrock and there are a number of national ones that are evolving as well. They all operate this layer, and they have associated permissionless has very thin governance. It's like maybe just a set of developers, but public permission ledgers like Sovereign have an entire governance framework. I chair the governance framework working group there. We spent 3.5 years on a complete governance framework for a layer 1 utility. Layer 2 is the agents and wallets that are needed for interoperable, verifiable credential usage worldwide. And these, I would like to point out, these are not the wallets you have on your phones today. Apple Wallet, Google Wallet, they're fantastic, pieces of software, but they're proprietary. They're controlled by those companies. It'd be like having a wallet where from a particular, bank or department store, it said, all you can put in here is what we tell you can put in here, right? No, that's not going to work. We need open standards like verifiable credentials and DIDs and an open standard protocol called DIDCOM for communicating between those. Layer 3 is the trust triangle. This is where we have issuers, holders, and verifiers. And what that has is what we call credential governance frameworks. That's the kind of governance you have over a MasterCard or a Visa as a credential that can be used every place. And layer 4 is the application layer. And that's where we get into entire digital trust ecosystems that use whole families of credentials from multiple issuers and multiple governance authorities, like the MOBI ecosystem I talked about, like the Internet of Education that is forming, like GS1 and the global supply chain. All of those are digital trust ecosystems that are forming at layer 4. So that's the complete stack. We talk about it this way: you take your requirements, you cast them into governance, and then you make your technology decisions. And that's what the Trust over IP Foundation was set up to do. It is, again, just launched at the start of May. It's all about standardizing and operationalizing the Trust over IP stack. It works with all these other organizations that are working on open standards or components of the stack to bring them together into a single overall infrastructure, just like TCP/IP. And we have these 4 working groups too on the governance and technical parts of the stack, and then what we call the Foundry working groups, which is where groups that want to say, I want to build either a layer 1 utility or a layer 4 ecosystem. They can come and incubate that work at the Trust over IP Foundation. And that's why we have grown from 27 members when we launched on the 1st of May to over, I think it's over 130 now in just 2.5 months. And that's, you know, reflects, I think, the level of interest in Trust over IP. So with that, I will hand it over to Dan to go deeper into a specific example.
Okay. I'm going to share. Okay. Share screen share. And this one. Okay. And finally present. Okay, cool. All right, so starting where Drummond left off with the Trust over IP stack. Yeah, just breezing through that. So yeah, again, leveraging a lot of, oh, so is this in the way? Let me minimize that. If you're seeing my screen. Okay, so everybody could see the practical example, known traveler digital identity?
Yep, we see it.
Okay, perfect. So yeah, so building on all the building blocks that that Drummond talked about, a real example of that, you know, the 3-actor, you know, makeup, composition of the solution stack, the issuer, holder, verifier. In this case, the holder is the traveler, the issuers are typically governments or airlines, and the verifiers are also typically governments and verifiers. But you know, going back to what even John said, you know, we want to make these digital identities private, secure, and easy to use. So, so the goal here was to put the traveler in possession of their identity attributes so they can selectively disclose specific information required by each service provider after informed consent. So that has a lot to do with the privacy, the data minimization, and putting me in control as opposed to Big Brother. You know, and then it also allows that's the benefit to me as a traveler, but it also allows the service providers like governments and airlines to determine the authenticity and integrity of information provided and if it's been revoked. So we have within this ecosystem the issuance of verifiable credentials, but also the revocation of them without the need to revert back to the issuer. Exactly as Drummond pointed out, the verifier has to have no direct interaction with the issuer. It just has to have that dash line, that trust. And we'll get back to that in a sec. And then issuers and verifiers can include public and private sector entities in accordance with the governance framework. A couple of related questions were asked related to this. But if we look at an e-passport as an example, your passport, you have one issuer, the government typically, that issues one attestation, that's an identity attestation typically. You cannot make any updates. You can't revoke that attestation. Your passport could expire. And oh, by the way, even though some people use it as a form of ID, the public sector does not have access to the ICAO's public key directory to check, as we say here, the authenticity of that document. They can check the integrity. In other words, if it's been manipulated, it'll show up in the checksum of this digital signature, but they can't check the authenticity. I'll get by in a sec. One of the other questions that was raised is, well, if I have a driver's license, how do I digitize it? So in known traveler digital identity, the practical example is, and what the government's agreed to was, you do a one-time create digital identity, exactly what I think it was Dina that asked. So here the government said that it has to be in person for security reasons, that the traveler one time during this whole pilot, which should have been in production except for COVID, they have to show up one time in person, present to the government their passport, in this case, not a driver's license, but you get the similarity. Then they do whatever inspections the government needs to do, like check the ICAO PKD and Interpol's stolen lost travel document. But ultimately, the authorities provide the verifiable digital identity attributes, like the passport details, including the photo, and they attest to it. That's how those little attestations get into my wallet. And that's one time. Now, for KDTI, for each trip, we're showing that, okay, now I'm the traveler. I have those government-issued verifiable credentials in my wallet. The last verifiable credential I need is basically at check-in, my flight information. And you'll see why in a second. So once I check in, the airlines will provide verifiable credentials that Dan is on this flight from whatever, Dulles Airport to London. That information now I could selectively disclose to, in this case, an airline, my departure airline, my departure security, like in the US, that would be TSA. Border control on exit, we don't have in the US in production. The Customs and Border Protection is doing a pilot anyhow. But then airline boarding, I would share my information with that same airline that now I'm boarding as opposed to check-in. And then my arrival government, which would be the UK government in this case. So before I even fly, I could share all that information ahead of time. So the governments could do whatever background checks, the airlines could prepare for my biometric boarding or prepare my check-in. I didn't put lounge access here because I didn't want to be presumptuous, but prepare for Dan to show up at the lounge, But what does this mean? I show this little icon of a face. So after I share that information once, after I get my ticket, I never have to take out my boarding pass or passport again. At check-in, because I shared my information with the airlines, they do a 1-2 few search of faces and say, oh, Dan, I see you're checked in on this flight. Just drop your bag at the bag drop. Faces required there only because of government regulations say that I can't just drop off a bag. That bag has to be associated with the carrier of that, to make sure that it can be tracked and traced to that individual. Again, I don't need to show anything at TSA checkpoint. I should just be waved on to drop my bag and have the physical security done. Again, no border control, but you can see it could be a seamless, just recognize my face, green light, gates open. Same thing with boarding. And they've been trialing this. Your face is your passport for boarding. I could, they could board an A380 in half the time using just biometric boarding. But the intent, and then when I arrive at the UK, what we're going to pilot is between Canada and the Netherlands. So in that case, when I arrive at the Netherlands, there's going to be a special line for KDTI. You don't have to do anything except go to that lane. You'll be recognized, and you're in the country. Yeah, so that's the overall flow. And then just going down a layer and mapping it to what Drummond was just talking about. and I did this kind of user-centric, user at the right, and all the PII, all my personally identifiable information is in the wallet. Nothing except for those public DIDs, as Drummond already talked about, is on chain. And you could read all the details here, but all my PII, all my verifiable credentials with these little certificate things are in my wallet. I could share some bits with the airlines, which doesn't include the green bit, whatever that is, but different bits with this government entity, different bits with this through selective disclosure. And as Drummond said, through these private channels, which are pairwise pseudonymous channels that are created with my DID as a holder and the DID of the, in this case, the verifier. We set up these private channels to share information. In the case of KDTI, we stood up our own blockchain. We would have preferred to use a public utility like Sovereign, or as Drummond said, like Bedrock is just being stood up now. Finland has their own network, but they're slowly emerging. And the reason why we created our own is really the government's preference. The governments of Canada and Netherlands wanted to get experience, hands-on experience. They wanted to own some nodes and understand what that's like. So, but we used we preceded the trust over IP governance stack, but it is cyclical, like Drummond pointed out. We're taking what we learned from this, putting it into trust over IP, so that trust over IP will inform future implementation. So there's a lot of governance. One of the other questions, again, I think it was Dina that asked, how do you make sure that an issuer is allowed to write to the blockchain? Well, that's part of the governance. And what we agreed, just like trust over IP will specify in that governance framework, we agreed within this ecosystem, which was 3 airports, 2 airlines, and 2 governments, who can write to the blockchain, what they can write, and what the data schemas were. So that's another thing that's here. What's on the blockchain are data schemas, not actual data, but what's the schema, what data is required, and in what format. So that's that. And then there's a 3-minute 43-second video that I want to fire up here that explains all this, but is a bit slicker. So here we go.
With the number of international arrivals expected to grow 50% by 2030, travellers need seamless ways to cross borders that also protect national security while protecting their personal data. The Known Traveller Digital Identity, or KTDI, is a public-private collaboration that enhances security efforts while enabling a connected journey for today's international traveller. The KTDI is the only global travel initiative of its kind. Travellers can share documentation and information from one verified identity with partners including government authorities, airlines, and hotels. The KTDI allows travellers to play an active role in travel security efforts by sharing their information proactively. Travellers always retain control over what, when, and with whom they share their information. Each data element shared by the traveller is verified, accurate, and consistent every time. This is made possible by the technologies of distributed ledger, cryptography, and biometrics. As more data and information is added, travellers build more enriched profiles that build trust with each partner interaction. Let's follow one example of what the journey could look like for future travellers. After travellers download the KTDI app and create their profile, governments provide and authenticate the traveller's identity data based on their passport or government-issued digital ID. Biometrics will link the digital identity with the physical person and their national identity document. When approved, profiles are securely stored and encrypted in individual identity wallets. These contain the original government attestation and additional attestations as proof of the traveller's history of border crossings, plane trips, and hotel check-ins. When a traveller shares required identity information, the attributes they share are checked and validated through encrypted links to their source information. Whether the traveller is booking a flight, boarding a plane, or entering a destination country, the travel provider or government authority can be sure that the information shared is authentic and verified by the issuing organisation. Travellers could also send their information to authorities in advance of departure, allowing travellers that are deemed low risk to be screened sooner and processed faster. Hotels could offer self-service check-in via facial recognition to ensure travellers are who they say they are. Throughout the journey, the known traveller digital identity creates one connected process to build trust, encourage travel, and allow precious security resources to focus on the areas of greatest need. Components of the known traveller digital identity will be championed by the governments of Canada and the Netherlands. Additional partners include Air Canada, KLM Royal Dutch Airlines, Toronto Pearson International Airport, Montreal Trudeau International Airport, and Amsterdam Airport Schiphol, in collaboration with the World Economic Forum and Accenture. The known traveller digital identity will be piloted this year, unlocking the power to change how we travel.
Okay. And, yeah, so yeah, so that was pretty much it. Yeah, I don't have to expand it. Yeah, we did talk about hotels in this. That was the intent. But as we got further into this project and just dealing with two governments and three airports and two airlines was enough. So we de-scoped hotels, and it did say this year. So this video was made pre-COVID. So it's probably going to be pushed out. We don't have exact timelines yet, but you know, we're in you know, still, you know, we're still in rollout mode. It's just been slowed down because of COVID. But yeah, so I should turn it back over to John at this point, right?
Thanks, Dan. Very good. This stuff is great. For me, it is. I learn something new all the time. And let's, we have 3 minutes, and there's some questions that I kind of thought of as you guys are going through this, and also a little bit related to some of the questions in the chat, but anyone in the chat can still submit questions here, but just real rapid fire, quick answer. Does SSI have some of the same problems as user ID and password, such as, you know, if I use my user ID, a lot of times it's my email, I use the same one. Can I be tracked across different services? Do I need to deal with two-factor authentication complexity? Can key recorders or hackers steal something from me and be able to use my identity? Real quick.
Wow. Well, we'll split them up. Username and passwords, one of the nicest things about this technology is it eliminates usernames and passwords. I even call it automatic authentication, because it's based on the using the private key with any connection that you set up. So you don't have to either remember or use the username and password. It's inherent multi-factor, and that's as far as I'm going to go. Dan, I'll hand the rest of the questions over to you.
Can I be tracked?
Yeah.
So you said I don't need two-factor. I get rid of user ID and password. Can I be tracked?
Right. So I'll pick up on that. So it goes back to those DIDs, right? So every time I set up a secure channel, I'm generating a new public key. It's kind of like FIDO, if you're familiar with that protocol. When I establish that channel, I'm using my DID, but that DID is a public key generated from my private key, and that key is new for every. If you're designed properly, is different. Even if it's with the same bank or whatever, I generate a new DID every transaction. So,
okay, so
yeah.
I can be a new person with the same entity with my bank every time if I want to be, or I can say, bank, you can know me, or I can even say, hey, bank and retail store, you can both know it's me, the same person, or I can be individual.
Exactly. I call that, it's intentional correlation. So the infrastructure says you can't be correlated anywhere by, and all the protections are there, and then you decide and can cryptographically prove where you need to be correlated.
Okay.
That's right. Because once I establish that pseudonymous channel and they say, please give me your name and your passport, well, then I'm disclosing that, through informed consent. So now they know it's Dan, if that's part of that protocol, right? But the infrastructure allows total anonymity and non-traceability.
Okay. If I now hold my identity, it's on my phone, it's in my possession, this data, can I lose it?
Yes, is a short answer. Now, and that's why the most reliable schemes, the properly designed schemes, have a backup and recovery mode built in. Those attestations are your files, secure files on your device, which could be a phone, it could be your iCloud, right? Those credentials are sitting there in a space that you control. And yes, if they're all on a phone in this example, then and you lose your phone, yes, you'd have to re-get all those attestations. If you have in the design that you have a backup and recovery scheme, then there you go. Then that's how you do it. It's not that simple, but ultimately that's what you need to rectify that situation.
Yeah. The way I put it, John, is again, hopefully, what survives in the market are well-designed backup and recovery schemes that are built right into the wallets and the services that you use. Certainly that's what Evernym's in the business of doing. And if that's the case, I will contend your digital identity and digital wallet is going to be quite a bit safer than this piece of leather. Right, it really is. It's not only much more hacker-proof, right? I mean, I do knowledge-based authentication for a refi at the current rates right now, right? It's just atrocious. I mean, if you know a handful of things about me, you can spoof my identity. With this whole infrastructure, you'd have to get a hold of my private keys, and there are ways of protecting those that are just so much stronger. And that's the kind of infrastructure we need internet-wide to really get away from the kinds of constant hacking and data breach situations that are going on today.
Yeah, that's good. So one last question. To make use of this solution, do I need to rip and replace? Can I integrate? What's the story there?
I'm the first one to say layering. No, it layers over existing systems. One of the hottest topics in trustworthy and SSI is how does it work and interoperate with federation protocols like OpenID or existing LDAP systems. I mean, I think a major part of Accenture's work and Dan's work is how do you put these things together? It's like the web. The web didn't displace all the corporate information systems that are out there. It layered over them and made it much easier to exchange information. This is the web of identity and trust. It will layer over and make it much easier for us to have trust relationships, but it does not require rip and replace.
Yeah, exactly. It does require this concept of a digital wallet, and what we do, the industry, not just Accenture, Evernym included, we create APIs that could be put into existing infrastructure, like in that airport environment. Today, you have to do passport inspection, whatever, and do that type of inspection. So all this is doing is saying, how do I get information to that entity? And that's why Drummond's saying you layer on. So if right now today you get Dan's information by doing a document swipe or have the airline send it to you, well, in this case, the information is coming in through a slightly different channel. So you just have to adapt to that channel of information exchange, basically.
Good. Okay, we should conclude this, and we do. Okay, so you answered the last question there. Dan, Drummond, thank you very much. This was really, really good, and this is a very valuable technology that's definitely killer app for blockchain, but also just a killer app for changing the way things get done and making great improvements in from just our lives, from cost perspectives, from risks, from even generating new revenue, from just lots of things. So privacy, security, very, very good. So thank you very much for taking the time to do this. For the audience, there are more forums and programs and events that Tech Titans is offering in July and August. And if you go to techtitans.org, you can see the full schedule, and you can even enter your email and be notified of events when things like this occur. And also the annual Tech Titans Award nominations are open until August 24th. And there's information online and nomination forms online. So it's a really great gala, essentially, that's recognizing some amazing achievements in North Texas, and a lot of fun and important to see, who's doing what in the region and recognizing those folks. So thank you everyone for attending. We are complete. Goodbye all.
Thank you.
Thanks to everybody. It was a great program. Thank you so much. Y'all have a great day. Thank you.